Okay, so we're going to look at our lab, the vectors of Jupiter High School. So we've learned about scalar and vector quantities and things like distance and displacement and speed and velocity. So what we're going to do is we're going to use a scale to determine distance and displacement, and we're going to practice finding resultants of vectors. So the scale we're going to use is 1 centimeter is 15.5 meters. So that what that means is 1 centimeter on this map is equal to 15.5 centimeters in the school. Okay. Or meters. Oh, look, I wrote the wrong thing there. It's like that doesn't make sense. All right. So now, and this is actually to scale because I measured the hallway. So what you're going to do is you're going to kind of travel on this map. Okay. So you're going to pick a starting point. So here, from the entrance of the school to the double doors in front of the atrium. So it says use the scale on the map and determine the distance in meters. So you're going to start off right here at the entrance of the school. Okay. And they want to know, well, I made this up, how far it is to the double doors at the front of the atrium, which is right here. So what you're going to do is you're going to take your ruler and you're going to measure. So if I measure that, it looks to be about, line it up, 6.6 or 6.7 centimeters. Okay. So what that means is, so let's say it's 6.7 centimeters. All right. So now if that's 6.7 centimeters, now I have to convert that to meters. So I'm going to take my calculator. And so 1 centimeter is 15.5 meters. So 6.7 times 15.5 equals. So that means that using the conversion, this is 103.85 meters. So we'll say about 104 meters. So now you're going to do that same thing all along, you know, going from place to place. Okay. All right. So let's go to some other parts of the lab. So what you're going to do, so remember the distance is how you go, and your displacement is from where you start to where you end up. So again, you're going to write on the map and show everywhere that you go. Okay. So remember, if I go from one place to another place to another place, the distance I added up and the displacement is from where I start to where I end up. Okay, now let's look at some of the other things. So if we look at, this says draw a vector diagram representing your motion, including your displacement. So this says in the space below, use the same scale on the map. So you walk 62 meters north. So I'm going to pick a starting point, and I walk 62 meters north. So I'm using the same scale on the map. So if I'm going 62 meters, I would need to know how many centimeters that is. So 62 divided by 15.5, so that's going to be 4 centimeters. And then it said I go 31 meters right. So now I'm going to say 31 divided by 15.5 is 2. So now I'm going to draw 2. Remember, that's a centimeter, that's 2. So now, the paper you have, I shrunk it. This is where I start. This is where I end. So what I'm going to do is, I'm going to connect those. And that's my displacement. Remember, this and this is my distance, and this is my displacement. So where I start is going to be my tail, and where I end is going to be the head of the vector. So now, if I wanted to measure these to scale, what I would do is, so this is 62, and this is 31. So if I measure this, this comes out to be like 4.6 centimeters, and 4.6 times 15.5, and then again, so I get about 71.3, but that's doing it to scale with a ruler. So when it says calculate your distance, you just add up 62 plus 31 is equal to 93. When it says calculate your displacement, I'm going to use the Pythagorean theorem, because that calculate is different than measure. So if I calculate it, I'm going to say 62 squared plus 31 squared, and then I'll do this on the calculator. So that comes out to be about 69.3. What happened to the G here? Calculate the angle of your displacement from the northernmost direction. So now I want to calculate, this is north, so now I want to calculate this angle. Now I can also measure it, because here it says measure it. So to use a protractor, I line it up like this. Okay, so when I'm reading this, this is 10. So this is 10, 20, that's 30. So this is maybe like 28 degrees when I measure it. And now when I calculate my angle, we're going to say tan of theta is opposite over adjacent. So the opposite is 31 over the adjacent is 62. So now remember, that's tan of theta. I could do that in my head, 31 divided by 62, but 31 divided by 62 is half. So that's 0.5, but that's tan of theta. So remember, on my calculator now, 0.5 second tan, and that comes out to be 26.56. So we'll say about 27 degrees. So you see here, I'm very close in my calculated value to my measured value. So this is just showing you how to do, and then you're going to do your percent error. Okay. So again, on the back part of the graph, when you're calculating your distance and displacement for some of these other questions, again, now it says you're going to your first period, honors physics, then you walk here. So then it says, what's your distance traveled? You add them up. If it says, what's your displacement from where I start to where I end up, I draw a line, and that's my displacement. Okay. So again, this is us. We just went over the last 2 days going over resultants and vector resolution. So this is going to help us a little bit understand vectors. That's it.